Hello, Chem 1 students. I found 25. Three of you. Three of you haven't come back. I'll just check who they are. One more missing. One guy missing. Who? 何偉林 are you here? 何偉林 no. Anyone who found 何偉林 no. In a previous lesson, was he here? Finally come back. Good. Full team. Now, today we would continue on the. We start to do some calculations work, but before that we would get mixed with the lab procedure. Now I don't know whether or not when we can come back, but the first. So briefly, the concepts of the lab procedure should also be noted up. So I would like to tell you something more about the procedures of doing this experiment. So we call it titration. Okay, we call it titration. So last time we talked about titration in the preparation of water-soluble salt, especially for group 1, right? Sodium chloride, potassium chloride. So titration, it is a practical method, experimental method, to measure the volumes of the two solutions that react exactly. So underline the term react exactly. It just reacts. So this act is a start of our talk. Okay, so here exactly that term exactly. From the measured volume and the known concentration of one of solution, you may find out the concentration of unknown, of the chemical species of unknown. So, and this titration method, it will give you some various application. Now, for example, determine the number of moles of acid found inside the vitamin C in some fruit juice, or maybe even you want to determine the amount of vitamin C inside the fruit juice. Okay, so you may also use that type of method. We call it titration. We call it titration, 滴定法. So this is our applications. So in chemical test, in chemical analysis, titration is also a very important measurement method, okay, for you to get to know what exactly amount of the chemicals found inside, in the solution. I repeat, is inside the solution. Okay, so we will call that a type of volumetric analysis. Why? Because we deal with the measurement of volume. We call it volumetric. volumetric. So it belongs to the undercategory quantitative analysis. Quantitative related to quantity, how much and chemical it is found inside a sample, how much content inside. While in the previous chapter, we talk about qualitative, quality. Okay, so quality in this sense tells you the identity of the chemicals. So remember, whenever you talk about analytical chemistry, 我哋講緊分析化學 we would mention both items. First of all, what this is, we call it qualitative analysis, and second is how much is this. So we call it quantitative analysis. 喺化學分析化學入邊一定要知道兩樣嘢，第一佢係乜，第二佢有幾多。So in this chapter we talk about 佢有幾多。Can you get my point? So this is what is it gives you a very basic stuff of this a titration. There are several different types of titration. Now, it's not necessary to be acid-base alkaline titration. It can be redox titration. It can be precipitation titration. So you will know it later. Now, for the first two types, one for acid and alkaline titration is the basic one. Okay, it's easily observable one. It's easily manageable one. Okay, so we start from this. So in order to get to know what this is as a titration, now you will have the following apparatus. So you may imagine, right? You've got a hand here, well, you've got the person of here. So you may imagine that burette is somewhat a very tall instrument, right? And pipette filler, the rubber one. Pipette filler, the rubber one. It is used to suck up the solution where you deliver it using pipettes. Pipette is a glassware to measure accurate the volume of certain chemicals. So our common practice of using pipette is 25.0 cm cube. But of course, there are so many different types of pipette. It can be 1 ml pipette, 5 ml pipette, 10 ml pipette. Now, for the first few, a very little amount of pipette, it is usually used in biology. While for chemistry, we focus on larger volume of pipette. So we may have, for example, 10 ml pipette, 25 ml pipette, and 50 ml pipette. Okay, so this is what you know about that use of pipette. 唔係淨係化學科會用 pipette 嘅，咁生物科都會用嘅。生物科嗰啲咧就係冇個筆嘅，咁啊長條形，右身有好多個黑度嘅，或者甚至乎有冇聽過 auto pipette 啊？有冇聽過 auto pipette？auto pipette 即係咩啊？嗱 ，auto pipette 咧係喺平時咧，如果你auto pipette is of this， 即係呢隻 auto pipette。It is this one. So it is commonly used in biology. Why is it so called auto pipette? Because you simply press it. Okay, you press it, you release the stops, and the plunger will go up, and the solution will be sucked up. So you may find the data here, right? The data refers to it is adjustable, right? You may adjust to get the volume that you want. So we call it auto pipette. 係冇型啊呢個，即係 the one that you see in TV news, right? You talk about, but of course, it is made by handmade, but you may see some other auto pipette in which we have got 5 or 10 auto pipette sucking up the solution altogether, right? It's done by machine. 咁呢個咧就係 biology 我哋會成日用嘅，即係都幾型喎。咁樣 auto pipette。咁我哋用緊嗰隻咧就係呢隻，傳統係用自己嚟啦 pipette。除咗呢個之外咧 we got conical flask. We have got a flask which is used to prepare a standard solution. We call it volumetric flask. Volumetric flask. Okay, volumetric flask. So this is something new apparatus that you may know. First of all, pipette, the one to deliver the fixed volume of solution. Second is burette, is for titration to determine the accurate volume of a titrant. And finally, volumetric flask. This is the place where you prepare the standard solution of certain certain volume. Okay, so you may have got 3. So you may see that. Okay, accurately delivering a fixed volume of liquid, deliver various amount of liquid accurately. Volumetric flask is used to when diluting or the preparing a solution. Okay, for example, 10 times dilution. Just like last time. How would you make that? So of course, the combination of this pipette and volumetric flask should be 1 to 10 in volume. If you want to make it as a 10 times dilution. Okay, you get my point. So if you have given 25 ml of a pipette, what is the volume of volumetric flask? It's 250.0 cm cube. Can you get a point? So this is what you know about the whole thing. So the conical flask, what is the use? It seems that this one, they even though I pour the solution inside, they will not give you accurate volume, right? So yes, that's right. Now, so for the volumetric flask, the grating inside would just tell you the rough amount, rough volume of the solution, but not an accurate one. So this is a place because of the shape. Because of shape, you have got a wider bottom, while it will help swell the solution easily without spilling over when you try to mix the reactants. So it is different from the conical, it's different from a beaker, right? Swell, okay? Swell with that action. So you may get, right? You may take a look on the screen where you may swell the action, right? So if you use a beaker, right, of this, so once you swirl, what will happen? You may see the volume, the water level will splash it very quickly, right? So if we've got a very large chance of having spilling over of the solution. But you use the conical flask because that one is a flat, more flat, while this one is narrow. Even though as well, you may have the solution just splashing inside, but you will not spill it so easily. So can you get the point? So it will tell you the difference between conical flask and the beaker. Can you get the point? So this is what I would like to talk to you about the use of different apparatus. Okay, is that clear? So 13.4. So first to start with, everything we need to tackle those procedure one by one. First of all, to get the standard solution. What is meant by standard solution? A very strange term. Standard solution, 標準溶液. So standard solution is a solution in which its concentration is accurately known. Underline the term accurately known, and this sentence is always it is just one of the FAQ, frequently asked questions in public exam. Accurately known. But wait a minute, Mr. Jun, how can we produce a accurately known volume, molarity solution, accurately known molarity? How? Now, first of all, you need to think of 2 ways, right? Solution, you need solute. And second, you need solvent, right? But of course, finally, what we are relating to is solution. So for chemists, we are so lazy to tackle all those. We just focus on solute and solution only. Now, no need to bother anything about the solvent, especially the physical quantities. Why? You will know it soon. Now, before you talk about the preparing standard solution, which means that we need a solute with a known mass and the solution which is known volume of solution, not solvent. 嗱，睇清楚啊 we need a known mass of chemical in the water, which means solute, and known volume of solution. Mr. Chin, how about volume of solvent? Why didn't we need to tackle that? Well, you need to, but you need not think of the accurately known volume. Why? Now, for example, if I have 1 gram of sodium chloride and I dissolve it to 100 cm cube of water, so what is the total volume of the solution? Is it 100? Is it 100 cm cube? Is it smaller than or larger than?
Larger than.
Somebody said it's larger than. You think of a 101 cm cube, but how many of you would think that is 101 cm cube? As I just said to you, 1 gram of sodium chloride and 100 cm cube of water. So what is the total volume of solution?
應該係多咗嘅，但係我覺得應該係多咗嘅，但係就唔一定係多一個，因為一個 gram 唔一定係一個 cm cube 噶嘛。
係你講緊鹽啊嘛，鹽嘅話 1 gram of NaCl is not occupying 1 cm cube volume。
但我唔知幾多咯。
你唔知㗎，其實 why would they mix them? It is not necessary to be 100 cm cube of a solution, but of course it's not 101. But do you mean that once I put that into the water, it occupies the same volume? The answer is no. 即係如果你話1 gram NaCl 我知道佢 occupy 0.5 cm cube 嘅 volume 啦，咁係咪即係0.5 cm cube 再加100 cm cube 就100.5 cm cube 咧？但答案唔係嘅，Why? Because in the solution, sodium ion and chloride, they are solvated. We call it surrounded by water molecules. So it will give you another strong attraction. We call it ion dipole interaction. So which will make the total volume of the solution of water become less. So strangely, if I add 1 gram of sodium chloride to 100 cm cube water, you may experience a very slight decrease in the volume of the solution. Believe it or not. But still, if you want to measure the mass of those sodium chloride solution, so what is that? So it is still 101 gram. But if you want to talk about volume of NaCl solution, so it is less than 100 cm cube. Very strange. Now for the first item, mass of sodium chloride solution is equals to 101 gram. Is easy understood, right? It's conservation of mass, right? But if you want to talk about NaCl volume, it will become smaller, but it will be quite difficult to comprehend, right? So the reason behind is that there are some formation of attraction force between sodium ion and chloride with water molecules. Well, we call it ion dipole attraction, which will make the whole structure more compact, more closely packed. So this is a very strange phenomenon I would like to share with you. Now you go back to the preparing of the standard solution. So which means that if you want to produce a standard solution, we don't need to tackle what is the final volume of the solution of the water plus the salt. Instead, we need to tackle the total volume of a solution, and that is the key point. We need not know the volume of a solvent. 你唔需要知啦，即係究竟佢嗰個水係咪有100 cm cube， 佔令到個 solution 有100 cm cube 啦？呢個已經唔係我哋重點啦。個重點係咩啊？你係要個鹽溶咗落啲水之後，跟住點啊？最後個 solution 係100.0 cm cube。嗱，呢個先係 is what we are looking for。But it is not how accurate the 100 cm cube of solution of water it is. It's no meaning. It's meaningless now. 明唔明？ So in order to prepare the standard solution, you go back to the solute. The solute, you need to get to know some of the points. First of all, they are of high degree of purity, 要純嘅。Second, and they should have a accurately known chemical formula. So, for example, if you in hydrated compound, just like, for example, copper 2 sulfate 5 water, you also need to get to know that 5 water. It is taken into account in the mass of that solute. 你冇理由唔計嗰5個水嘅，嗰5個水都稱埋落去嗰個 copper sulfate crystal 度嘅。And 3 is chemically stable. So that's why if you have sodium nitrate, for example, you cannot make standard solution of silver nitrate. It's because silver nitrate can be decomposed under sunlight easily. And it cannot use to absorb moisture from the air. 咁有冇例子啊？有邊啲唔得？例如 sodium
oxide
calcium oxide 係啊，但係 calcium oxide 根本就唔會用，唔係好用嘅。但係所以咧 calcium oxide 咧，我哋唔會開 calcium oxide solution 嘅，我哋唔會咁開。有冇人開 calcium hydroxide solution 啊？會，不過佢唔會係 standard solution 咯。因為咧佢入邊佢又係唔係好溶。嗱，記住佢要係溶嘅。It is completely soluble in water。見唔見到下一個點？嗱，所以熟石灰啊嘅溶液就唔得嘅。我哋唔會話熟石灰溶液開標準溶液唔得嘅。但係如果你話氯化鈣 calcium chloride solution instant solution you can。但係邊一隻會係吸濕咧 ？sodium hydroxide 自己寫乜嚟 ？sodium hydroxide 就吸濕啊。咁所以咧，我俾啱 sodium hydroxide你整隻 instant solution 咧就唔得嘅。OK 得唔得？And react rapidly or completely with other substances used in titration。最好係啦，你唔好放咗落去，等好耐都咪會 react 啦。As a high molar mass， 有一啲有關 molar mass 嘅。如果 molar mass 大嘅話咧，喺稱嘅角度上邊咧，個 error 就細啲嘅。咁如果啲 chemical 係符合以上條件咧，就叫 primary standard 啦。得唔得？嗱，頭先同你講咗啦，有幾隻係唔得㗎。嗱，簡單呢一個 sodium hydroxide 係唔係並不是攞嚟做 primary standard 啦。Why? Because it is said to reabsorb moisture in air. OK？ 咁啊，頭先都講咗㗎啦。咁所以咧，you cannot just weigh the sodium hydroxide accurately, and you can tell the solution having a known molarity. Why? Because some part of them may have absorbed moisture in air, and worse still, part of them may have absorbed carbon dioxide in air. So it would affect our overall molarity. OK？ 咁有邊啲得咧？阿 Sir 問我話有啲唔得，咁邊啲得咧？又係例如 oxalic acid crystal 呢個 ethane direct acid crystal oxalic acid 啦。Or anhydrous sodium carbonate they are suitable for making as a primary standard. Okay, primary standard, which means the chemical that can be used as the standard solution, simply by weighing accurately the solute and dissolve it in the known volume of solution. 跟唔跟到？係用落去個溶液度，已知體積嘅溶液，已知份量嘅鹽用落去已知份量嘅用咗落去水入邊，變成已知份量嘅溶液，得唔得？記住啊，sulfur嗰個數咧，我哋係唔需要度得準啊。最緊要係咩？個 solution 最後係有幾大個 volume 先。嗱，呢個先係最基本嘅嘢。Okay, is that clear? So in the following minutes, I would like to show you one video where to talk about the preparation of standard solution. 我哋有兩隻嘅唔同方法嘅，17.4同17點咧，其實咧呢度有兩隻唔同方法嘅。你自己望一望先嚇。嗱，第一個咧係咩咧 ？It is used to prepare standard solution using dissolving a salt. While the second one, you are going to prepare standard solution by dilution. You'll be given a solution, and you are going to dilute it to the times according to the instructions. Can you get the point? 但係呢度有兩隻嘅。So we come to the, I would like to show you the video now. Let me see.
From calculation, 3.15 grams of solid ethane dioic acid is required to prepare the solution. First, weigh an empty dry weighing bottle. The mass is 10.0192 grams. Then add about 3.15 grams of the solid acid to the bottle. Weigh the weighing bottle and the solid acid. The total mass is 13.2294 grams. Tip out the solid acid into a beaker as much as possible. Re-weigh the weighing bottle and any remaining solid acid. The total mass is 10.0217 grams. By calculation, the mass of solid acid used is 3.2077 grams. Add 100 cubic centimeters of distilled water to the beaker. Stir with a glass rod until all the solid acid has dissolved. After dissolving, transfer the solution to the 250 cubic centimeter volumetric flask with the aid of a filter funnel. Wash the beaker with a little distilled water several times. Pour all the washings into the flask. Wash the glass rod and funnel in the same way. Pour all the washings into the flask. Add distilled water to the flask until the meniscus is about 2 centimeters below the graduation mark. Add distilled water using a dropper until the meniscus reaches the graduation mark. Stop at the flask. Turn it upside down several times to mix the solution well.
Okay, now you may see the video. Now I would like to ask you some questions about the whole procedure. Now, what do you feel about the procedure? 好鬼繁瑣啊！你有冇留意到？好煩啊，好多步驟。Now, tell me, what is the ultimate goal of doing so many procedures inside? 其實搞咁多步驟嚟做咩咧 ？Why are there so many procedures? 咪咯，
佢要確保佢最後整出嚟個 solution 係有佢即係已經 dissolve 咗佢本身要嘅數量嘅嗰個 solution。
Yeah. So in other words, you are going to make sure that the solution would have the accurately known molarity 嗱，一定要知道要搞咁多嘢咧，你要確保你個溶液啊，佢哋嘅濃度係啱嘅，又係已知嘅，準程度係高嘅，得唔得？好啦，咁我哋咧就you want to refer to the book 留意下佢哋入邊有咩步驟係做咗呢類型嘅確保嘅？有冇留意到佢哋嘅步驟？例如頭先我哋做咗啲咩？稱鹽先啦，係咪啊？稱鹽係第一個步驟，係提高緊佢哋嘅準程度嘅。咁佢個 electronic balance 咧，佢哋有冇留意到佢個小數點啊？去到幾多個？
即係我頭先睇3個定4個啊，係
小數點喎，
係
4個小數點咁犀利。
5個6個有。
嗱，小數點後嘅一個位啊，我講嗱，我哋咧 Cam Lab 咧，我哋嘅榜咧就係幾多咧？就3個小數點嘅。咁係點樣嘅咧？就唔係你 Form 1、Form 2我哋用緊嗰啲嘅。我哋有個玻璃罩嘅。We have got we have got a shelter to cover the electronic balance. Why? Because that if you have the measurement of highly accurate mass, which means that the weighing of anything here or any airflow nearby will affect that reading and they will fluctuate. So that's why if you see the electronic balance having a shelter above it, so you may predict that it would have a very high accuracy. 你明我講咩？通常如果你見到個磅咧，上面有個罩住咧，大部分情況都係㗎啦，就係佢話俾你聽呢隻磅咧係應該好準嘅。點準啊？點準法？包括係咩啊 ？You blow something above the pan， 譬如你特登去吹浸氣落去咧，the reading will also fluctuate， 係咁誇張嘅。咁呢啲磅咧就係好高嘅準程度啦。第一樣嘢3個 DP 嘅，我哋喺 lab 入邊嚟講係3個 DP 嘅。仲有冇？點樣計準啲啊？第二步佢做啲咩啊？Accurately we weight the empty weighing bottle plus the remaining acid molecule。咩意思啊？佢做緊啲咩動作？呢個係準嘅動作，係做啲咩啊 ？Weight by difference。嗱 ，weight by difference 咧係第二個 technique 嚟嘅。點解咧？咁唔係攞個吉嘅樽稱，跟住就倒啲鹽落去，咁啊收工咯。跟住我倒啲鹽，即係2個讀數啫嘛，一個吉嘅樽，一個吉嘅樽加啲鹽，咁我咪計完咯。咁點解仲要再稱多次咧？
因為可能有啲剩喺嗰度。
係啊，有啲剩㗎。Any remaining acid crystal, they are still found inside. In other words, what you pour into the with distilled water for dissolution is not containing the exact amount of the solute. 所以咧，我用 weight by difference 嘅方法，明唔明？咁我哋稱咩咧？就係我要稱埋呢一度就剩翻咧，你就知道冇咗有幾多個鹽咧係溶咗落去呢一度啦，得嘛？我就係一定要知道呢個要 accurate 嘅。所以咧，佢落咗去幾多？嗱，先係關鍵啊！落去呢度幾多係關鍵，清唔清楚？咁所以咧好麻煩 ，weight by difference 㗎。好，第3點，邊度係要好準啊？呢個啦，要溶晒嘅喎。嗱，記住啊，要溶晒佢。溶晒佢之後，咁你睇下下邊個要做啲咩？倒落去咯，咁一倒落去咧，we try to use the filter funnel for help to guide the flow of the solution and pour it into volumetric flask. Now in this case, we have 250.0 cm grip of volumetric flask. 跟住咧，呢度又係啦，麻煩嘢啦。呢度第4點係做咩
？To ensure that there is no solution left in the beaker, on the glassware, or on the funnel.
Yeah. So you have to make sure all the solute have been poured into the volumetric flask. Why? Because while you have dissolve the solution and you pour it into the volumetric flask, the glass rod, the filter funnel, the beaker, those 3 places will have some solute left behind. Okay, so what is the hidden message? Even though I mark the meniscus, the bottom meniscus really reaches the graduation mark, that solution is not accurately known molarity. It's a little bit dilute. It's a little bit lower the concentration than our expected one. Why? Because those solutes is found in here, and here. So that's why you are going to rinse the beaker, the glass rod, and the filter funnel well with distilled water. 點解要洗啊？就係咁解啦，因為呢度嘅鹽咧，仲可能係黐咗喺個 beaker 度、glass rod 度、filter funnel 嗰度，所以就攞水沖啦。好啦，攞水沖。咁你沖完嗰啲水咁點咧？嗱，呢度好特別嘅 ，you are going to pour the washings into the volumetric flask。即係話我沖完呢啲之後要倒翻落去嚇，得嗎？嗱，沖完呢啲有啲紅色嗰啲嘢，我最尾要沖晒落去咪？沖翻晒落去個 solution 度。咁就唔係沖完洗完就倒啦，明唔明啊？倒翻落去。其實咧呢啲你媽咪咧，你媽咪煮餸咧都會有呢啲咁嘅傳統智慧嘅，諗唔諗到啊？有㗎，你幻想一下，你話你諗下，好似咩？好似煮餸咁樣嘅，點解啊？For example，屋企人有冇做過呢啲嘢？我有啊，我都有咁做呢啲嘢。嗱 ，for example, I have got a bottle of oyster sauce. You know that oyster sauce is somewhat very thick, sticky paste, right? So, if I pour the last spoonful of the oyster sauce into the cooking pot for cooking, for example, so you may have some oyster sauce left behind. So what would commonly your family members do? 係啦，唔好嘥嘢咁點啊？ You pour the water into the bottle and shake it, and shake it, and then you pour those washings into the pot again. 明啦嘛？嗱，馮家謙都明啦，咁應該大部分同學都明。
係咪都啲洗頭水嗰啲都係咁啊？
係咪啊？即係係啊，啱啦，洗頭水係啱啦，你平時都係㗎，唔好嘥嘢啊嘛。你剩翻少少又擠唔到出嚟，咁點啊？加啲水落去咯，加啲水落去就擠咯。咁其實咧都係類似嘅講法嚟嘅啫。明唔明？嗱，即係唔係話啲 cam 嘢特登背，唔係你諗下你平時你都會做嘅嘢嚟嘅。咁確保咩唔好嘥啊？咁喺呢度嘅所謂嘅唔好嘥係咩咧 ？We try to make sure the molarity of a solution is accurately known。頭先咁辛苦，稱到咁準，係嘛？咁你嘅係 make sure 全部倒晒落去啦。嗱，如果唔係你係嘥咗，得唔得？跟住點啊 ？You're going to add the solution until the water level, we call that meniscus, the bottom of the meniscus. So what is mean by bottom meniscus? This is the meniscus, the curved surface. Okay, we call that meniscus. So we call that the bottom of the curved surface. We call that bottom of meniscus. You talk about the same thing. Okay, just reaches the graduation mark. We call that graduation mark. Now, this is the only line to tell you the volume of a solution. 你諗住今次你想準備250.0 cm³個溶液啊嘛，咁加幾多水啊？嗱，加幾多水唔係重點啊，係咩啊？我係要加到啲水同埋啲落去溶液入邊，直至到個溶液個體積喺度250.0 cm³。嗱，呢個就係重點。所以咧，我係唔需要去擔心我加嗰個水係咪240點幾啊、250點幾啊？呢個唔係我哋擔心嘅嘢。我就係要知道個 solution 最後係250.0 cm³啫。明唔明白？好 ，get 到啊？好 ，second questions 問下 form 1嘢先，鄭學明 ，Why would have the water level a curve surface? Why is it a curved surface but not a flat one？ 點解唔係平嘅咩？啲水啊，啲水位啊，個邊邊硬係要屈咗上去嘅。點解嘅？好，大家上網揾下，話俾我聽，點解水會係咁特別嘅？
係咪表面張力啊？有啲
係表面張力 is because of surface tension。嗱，同水有關嘅嘢，同埋溶液啦，佢哋個 curve surface 係咁嘅，就會係咁樣喺個邊皮個位咧就會咧up 過嘅，線咗上去。點解會線咗上去咧？就係因為咧呢度嗰個水之間嘅吸引力咧係唔平衡啊。咁啊，因為佢一邊咧係變咗個壁，掂咗個壁啊嘛。咁所以咧佢就最尾個 overall 嘅力咧就向咗上，咁啊擠咗上去。咁但係啦，如果我去，譬如啦，我放一個5蚊銀啦 ，we try to apply a water of drop of water。Okay, you try to put it drop by drop until somewhere, and it will give you a curved surface instead. Now it is also a phenomenon of surface tension. Okay， 都係嘅，都係講表面張力嘅。But that the curved surface is a curve upward。嗱，大家都係有啲唔同嘅，係嘛？嗱，水銀唔係㗎，水銀咧，如果我真係有呢啲黑度睇咧，水銀就咁嘅，個 curved surface will become this is that 係咁嘅，就唔係你哋會 curve upward instead of curve downward。Mercury 就咁啦。OK， 好特別嘅。嗱，你要計到佢啱啱好咁咧，就代表緊250.04 嘅啦。留意加水嘅方法啊，用 wash bottle 就快啊，但係 dropper 咧就精細嘅，準確。你隻手易就啲，擠過籠嘅機會係比較少啲。And afterwards, what should we do? We need to stop at the flask and invert the solution upside down for mixing thoroughly. How many times? About 10 times. 大概啦，向上向下熬10次。咁我要一落去，我點樣熬勻佢咧？其實我靠咩？我哋要靠個 bubbles。You try to make use of that air bubbles for help. Once you turn it upside down, what happens to the bubbles? They will flush upward, okay, and they will help mix the solution. So, for that action, you should do it very proper. 你要做呢個動作咧，要比較純正嘅，即係咩意思咧？而家我 show 俾你睇，而家係咁啊嘛，呢度有個 air bubbles 啊嘛，你要倒嗰陣時咧就唔係咁樣，阿 Sir 咁是但啦咁樣。嗱，如果 while you do such action, what will happen to air bubbles? The air bubbles will still stay on the top of the flask instead of the bottom. But once I do such action, take a look on the bubbles. 其實咧 they will just flush it outward. And they will help mix the solution more thoroughly. And I do that action. Can you get my point? So focus on the air bubbles and you can get what I mean. So we are going to do such instead of this. Now, even though you do this, those solutions which stay in the bottom will not get mixed well so thoroughly. Can you get my point? Only by this. You're going to do such action 10 times. Is that clear? 明唔明 ？So this is the first part. Any questions？ 知啦嘛？咁第二個方法啦，就溝稀啦。溝稀嗰個就易啲。如果你陣間你睇得明呢度咧，又係啦，用翻同一個腦去諗啦。就係我哋陣間咧會 try to show you some detailed procedures and try to tell me what other procedure is needed to make the whole process more accurate。究竟佢做啲咩動作？係話俾你聽咧，嗰個 measurement 係 try to make it more accurate。Take a look。
To prepare 250 cubic centimeters of 0.1 m sulfuric acid, to 25 cubic centimeters of 1m sulfuric acid is required for dilution. The apparatuses needed include a 25 cubic centimeter pipette, a pipette filler, and a 250 cubic centimeter volumetric flask. First, wash the pipette with water. Suck sufficient water into the pipette to fill the lower stem. Hold the pipette horizontally. Rotate it gently so that the water washes the bulb and the upper stem up to the graduation mark. Let the water run out. Then wash the pipette with 1m sulfuric acid. Use the pipette and pipette filler to deliver exactly 25 cubic centimeters of 1m sulfuric acid into the volumetric flask. First, put the tip of the pipette well below the acid surface. Suck up the acid until the meniscus is 2 to 3 centimeters above the graduation mark. Then use the forefinger to control the flow. Release the solution until the meniscus reaches the graduation mark. Transfer the acid into the volumetric flask. Allow the tip of the pipette to touch the side of the flask. Do not blow out the last drop of acid in the pipette. Add distilled water to the flask until the meniscus is about 2 centimeters below the graduation mark. Add distilled water using a dropper until the meniscus reaches the graduation mark. Stopper the flask. Turn it upside down several times to mix the solution well.
好，有冇留意到呢兩個都係做 standard solution 嘅？咁第二個方法係咩？We try you will be given a original solution already, and you are going to dilute it. How many times of dilution does it have in this case? How many times? 抽起咗幾倍啊
？10倍。
10倍啊 ！The combination of the pipette and the volumetric flask will tell you it is 10 times dilution. So, for example, if you are going to have a if you are going, why do I say that 10 times? Because you've got 25.0 cm cube at the pipette, and I put it into 200.0 cm cube volumetric flask. OK， 咁所以如果呢個咧 we call it 10 times solution. But for example, I've just said to you, I've got so many different types of pipettes. If we're going to have a 10 ml of pipette, I dissolve it into 250. So how many times of dilution does it have? 10 ml 變250，幾多？ It's 25 times. Okay? Can you get a point? So we are going to have a different combination of the volumetric flask and the pipette to target for the number of times of dilution, the solution you are going to have. Do you understand? 我哋就要需要去睇睇咧個 pipette 就同埋個 volumetric flask 嗰個相應嘅 比例咧而定究竟我溝幾多倍啦，得唔得？咁可以呢兩個都咁做。咁問題係你啦，咁溝起嚟做乜啫？嗱，我開 stand solution 我明啦，咁溝起嚟做咩？點解要溝起佢咧？但 there should be some reason behind, right？ 咁多嘢，咁我應該有啲理由㗎，溝起佢。諗唔諗到啊？點解要溝起佢？溝起佢做咩？ Now we come to the titration. We try to end this lecture today by take a look at the titration. Now try to think of the whole thing. In case we are going to do the titration. Now this time is different from activity which is 你見 activity 17.2咧就 sodium hydroxide with ethene dioxide， 係做 chloric acid with sodium carbonate。今次咧我 show 俾你睇嗰個咩咧？就係 sodium hydroxide 對 HCl。嗱，見到佢哋 common point 係咩咧？就係一隻酸一隻鹼嘅。咁你留意一下，點解要溝起佢？點解要溝起佢？你要留意下。其實仲有好多呢啲片，你見啊，呢度有好多片。咁我轉頭一次過俾埋你哋，翻去參考下。
Titration of dilute hydrochloric acid against dilute sodium hydroxide solution. This is a burette. Wash the pipette with water.
留意下呢個步驟咧，我哋又唔會叫你咁樣做噶啦。呢個步驟係一個好差嘅步驟啊，因為咧你留意下佢點樣洗支 pipette， 佢攞 wash bottle 喺上面擠落去嘅。咁一上面擠落去有咩問題咧？你留意下，一擠咗落去嗰陣時咧，呢個地方濕嘅，因為呢個地方濕嘅。呢個地方濕嘅話咧，其實即係濕係咩？係水嚟噶嘛。咁所以咧，我哋一陣間去做一啲washing 啊，或者 deliver 啲 solution 時，如果呢度有水咧，其實係會溝稀咗佢原本呢個 pipette 入邊嘅 solution。嗱，咁呢個動作係唔好嘅。第二就係你個 pipette filler 咧就掂口噶嘛，掂住佢咧，其實你個 pipette filler 都係會污糟。咁所以咧呢一個步驟咧，就我哋唔會咁做。咁唔係咁做，用咩方法洗啊？咁就唔用 wash bottle 啦，攞 pipette filler 直接就泵下邊啦，下邊整一個 beaker of water and try to suck up and do the following action。睇清楚陣間人哋個 action 係點樣做，喺下邊索啊，下邊索啲水上去。
Then wash the pipette with hydrochloric acid to prevent the water left inside from dilute.
係啦，呢個步驟最好，即係話咧，你攞水洗咧就唔好佢咁洗，你直接好似用洗酸嘅方法洗啊。嗱，留意第一個步驟攞水洗，攞 DR water， 攞 distilled water 洗，跟住攞酸洗。
Diluting the hydrochloric acid used in titration.
點解咧？點解要攞酸洗？明明攞水洗咗啦嘛。
Suck up 25 cubic centimeters of hydrochloric acid using the pipette.
留意住你個 mask 點啊 ？We try to have a volume fluctuation mask here while the water level is above。咁所以你會留意到，你明點解阿 Sir 話我唔中意喺上面攞水支落去，因為咧有機會溝稀咗。嗱，第二你有冇留意到佢嘅做法係咩 ？Try to get more than 25 ml and then adjust until it is 25. How to adjust？ take a look. They try to use a thumb, index index finger for help. Okay, you never use a thumb. You use index finger to help. Try to adjust, and then the water level will drop. 你攞隻手攞隻食指啊嚟撳住嗰個pipette， 咁啊慢慢喐咧，調校到咧佢哋water level just drop back to the graduation mark, and this is 25.0 cm cube.
Transfer the hydrochloric acid to a clean conical flask. Allow the tip of the pipette to touch the side of the conical flask. Wash the burette with
頭先佢話咩咧？咩 allow the tip 咩嘅
to
咧？
touch
咁佢就咧原來呢個 solution 咧去到最後咧嗰個 solution 咧去到尾嗰陣時咧，呢一個位嗰個 tip of the pipette 咧原來有少少水剩喺度嘅，因為surface tension 嘅問題。咁所以呢個點咧 never blow out。Never blow out the last drop. Instead, you try to allow to touch the tip of the pipette to the side of the conical flask. 一掂咗落去個玻璃邊度咧，其實有少少都會流到出嚟，但係最後都仲有掛住喺入邊嘅。嗱，佢計好咗㗎啦，你唔好拎佢出嚟啊，得唔得？你唔好拎佢出嚟。呢個你哋要知嘅。咁啊，呢個要 carry up practice 嗰陣時候會再睇多一次。
the side of the conical flask.
見唔見到有仲有 air bubbles 㗎？呢個頂嗰度，呢個有黑度，即係有兩畫嘅，呢度一畫，見唔見到？呢度呢一畫咧，話俾你聽咧，呢度係有啲 air， 呢度係 solution 嚟嘅。咁你留意下個黑度咧，最後係冇咗嘅。一冇咗，你話俾你聽咩咧？你就係啲 bubble。
Record the initial burette reading. Estimate the amount of sodium hydroxide solution needed to speed up the second trial of titration. Notice the colour change. Slow down the running off of the sodium hydroxide solution when the colour is about to change. Record the final burette reading. Repeat the titration 2 more times and take the average of the readings of the last 3 titrations.
係咪好恐慌啊？嗱，一陣間咧，我會一陣間會 send 翻呢條 link 出嚟俾大家，可以再望多次。咁一陣間2點鐘翻嚟嘅咧，我哋會再講啊。我哋會問多少少入邊嘅內部問題，我而家唔講住，得唔得？好，咁我哋一陣間2點鐘再講，拜拜，食咗飯先。
Titration of dilute hydrochloric acid against dilute sodium